Hi, I am Goran, I am from Zagreb, and I am a long-time member in Radiona. This work was made for the exhibition. It was an exhibition about drawing, so it was called Drawing Machines, and every member, actually many members, created different types of projects, and the work is trying to generate the pictures from the natural elements. So in this example, in this workshop, we will use the water elements, and from the water elements, we will try to create a picture. This work is written in the Python, and we are using OpenStreetMap libraries and PyPlot libraries. So we will draw a picture on the plot. We will plot a picture with the PyPlot, and we will get the water elements from the OpenStreetMap. Later in the projects, we are using OpenCV for the checking some pixel numbers and to get more out of the generated pictures. This video will be available after workshop, so you can watch it again or watch it slowly, and yes, so take your time and enjoy the workshop. Okay, so first thing we need is the Python for Windows, so you can use a search engine to search for the Python. You just go here, so it's python.org, and you can download the Python here. And you can just continue with the installation. Although I already have it installed, so I will not install it. And after it is installed, you can just type the Python here, and you can open the IDLE for the Python. And this is your starting point. So from here, you will open the files from the workshop. Next thing we will download is the code for the workshop. So we just go to this repository, and we go to a code and download zip. You can just use 7-zip to extract this folder, and it will be here. So we'll go here and here. You can probably go with right click and edit with IL. Yes, and you will get the code. So we will do it like that, or you can go here, file, open, workshop, so you have other parts of the workshops here. So next thing we will need some dependencies. So it will ask you for some libraries, as we don't have them installed on Windows. So we can go to run module, and you will get the error. So the error is about that the module is not available. So we'll need to find this module and install it. So we can check on the search engine. Okay, to install the module library, we will need the Python console, so you can run Python, and you can go to this. No. Okay, so to get the module, you need to go to command prompt. So you just enter cmd and go to command prompt, and you just run pip install. Oh, I already have it, so it's pip3 install, and module. Okay, now it will collect the module. Okay, you can leave this window as we will need other modules, and you can just try to run again. Okay, we are missing the right tools. and after installing the module, you can use you can just type idle, and it will load the Python idle shell. So from here you can open file. Okay, and you can now try to run it. And okay, it is finding the module, but it is failing because the city is wrong. I will explain this in the tutorial. Okay, run module. Okay, now it is getting the data, and it is doing the same thing as it will do in the Linux. You will need to do the same for the other parts. So if we load the part 2, okay, this one is already installed, but you can load the last. So you will need to get this. So you just need to type pip install Python. Okay, and just rerun idle. We will see if it's working like this. Okay, run. Okay, now it is getting the cities. And it is getting the pictures.
So before continuing to the workshop, I will show you how to install the modules on the Windows, on the libraries, and it is the same to install the libraries on the Linux. So in the Linux you will just type pip install and the name of the library. So let's do that. For the start you need to go to this repository, so it's GitHub. It's my name and OpenStreetMap drawing machines. So the best, actually the easiest way to download the code is just to go to code and download zip file. You can then save the zip file and extract it in your folder. You will get the same folder structure as here, and we will actually start from the workshop directory. But you can also use the Git if you are familiar with it. So you just copy this link and you can then type git clone and wait until it downloads the code. After you have the code on your computer, you can just go to the folder and we will go in the folder workshop. So we have few parts here. I will probably add parts additionally and record it, but let's start with part 1. So here we have the Python file, and you will just use it like this: Python 3 getting OpenStreetMap data. So you just try it like this, and it will fail as Berlin is too big city to get all the informations, but you will see now. So we will wait a bit. Now the code is downloading data from Berlin, but it cannot build the geometry as it's too big. But okay, now we will edit we can do it like this. Actually, for editing you can use any editor, any text editor. I am using Sublime. And here it is. This is the first code we will check. So this is the Berlin is too big, so it has the areas, and you will need to figure out how to get each area separately. Zagreb has only one area, so you can just take the Zagreb for the sample. Okay, let's try this. So it's the same, so Python 3 and the Python file. Now it will download the data from Zagreb. And it will just note how many objects it has found. So let's back to the code. So in the code we just enter. So this is the first thing we will learn. So we need to import the OpenStreetMap Python tools to get the things we want. So for example, we will check for the water in the Zagreb. So everything that is defined as natural water, we will get it. So it will get the rivers, lakes, and those things. So you can also find on the wiki of the OpenStreetMap, you can find what else you can use as a natural source. So you can probably use trees or something, but water looks quite nice. This is just a variable where we store the city, and we set the city to some city on the map. So you can open the OpenStreetMap and check for the city. Okay, so we can so Zagreb is here. I am here in Zagreb, and you can select also any other cities on the OpenStreetMap, but be aware that the city needs to be smaller if you use current code. So we can choose, for example, Karlovac. So let's do the Karlovac. You just save the code and then run it with your Python. Now it's downloading the data from Karlovac. Karlovac has 4 rivers, so it may have, okay, it has just 27 objects, so that are mapped as a water. So, and how this code works exactly, so we have the just one more variable where we will store the query of the city. Yeah, here is the link where you can find more things that you can get as a key natural. This line actually puts in the variable query, it puts the query needed to get all the natural from the area, and area is the city. So from the city get natural water, and if this query actually, this will try, if this query fails, it will print the query build failed, and if not, it will try to get the query results out, and if this failed, then it will print it is failed. So in this code we just are, so we here we get the objects, so all the objects that are natural water, we get them. We set one variable that will be used for counting those objects, and we just, so the results are stored in the results and are set as the elements, and they are set as the elements water. So we just write code for all waters in the elements, do the loop. So it will, for each element, for each water element, it will do the same code. So it will put the water geometry in the data string, and it will add 1 to the counter. And once it's done with all the water objects, it will just go to this final line, and it will print the line how many objects is found. This is end of the first part of the code. If you have some uncertainties or you are missing something, please contact me on the chat, and I will explain it more. But actually it's really simple code, and we just want to get count of the object. So, and you can experiment with any city, and you can also experiment, for example, with another query. So you can set the scrub, I don't even know what this is, but I have it saved. So you can experiment, so how many scrubs are in Karlovac. So let's see if this will work. It will again download the data of the scrubs from Karlovac, and it has found 100 objects in Karlovac. Part 2, we can open the code in Sublime, and we can start from here. Okay, and here we have the 4 points, and we will use the pyplot to show the graph on the screen. We will just draw those 4 points and connect them. And for using we are using pyplot as it's the easiest way to draw on the screen, and OpenStreetMap will give us points. Actually, it will give us polygons that will be drawn, so we will just draw them by the pie plot. And if you want to use this pie plot, you need to import those libraries, and you can actually start with the graphs. I will just get all the information about this graph and print some minimum maximums. I will show the graph here. So let's try to run this code. So it's here, and our graph is here. So it's just the 4 points that are connected and some information about the minimum and maximums that we will use later. So the other things we want, okay, just I can run it again and I will show you what is. So we don't want some things to be on the, when we will have it, we will use the OpenStreetMap, we don't need those axes and a few other things, so we just want them to be removed. So first thing I can do is remove the axes and just save this and run this again. This is it. So now that we don't have the x and y axis. Okay, and what we want to have that, so when we will draw the picture, when we will draw the water, we want lots of randoms in the code, so that we don't get the same pictures more again and again. So we will use the zoom. So zoom is actually used like this. So we need to enable interactive mode or zoom will not work. And yeah, we will just have show after we have zoom. This will zoom just once. Oops, no, it's not, we still don't need interactive mode. Okay. So this is when we zoom once, and maybe we can zoom more than once. So this was one, and we can. So for the exiting the code, you can use Ctrl C. Okay. And this is times 5. Oh. Okay, and we can zoom, for example, here 5. Okay, and then we get something like this. Okay, so for exiting this code, you can close the graph, but you can also press Ctrl C, so it will end the code. Okay, later we will use the close graph with enabling interactive mode, so we can close one graph and show another. So for the part 3, yeah, we will combine those two from the first. So so now we have a bit bigger code, but code is actually everything from the first and from the second part. We just have one more thing that is timed, just some way for the weight. So here we have another city, and the same type of query is used. So we have the scrub water, and for all the waters we will now use the polygons and we will just plot them on the graph. So let's try this first. So it will first download the CISA because we don't have it. Oops, and it will. Okay, this is a bit too fast, so we'll set this to 1 second. Okay, and we'll try to draw it. So okay, we can run this. Okay, so now we have the graph of each polygon that is in CISAC, and it's set as a water polygon. It will list all. It doesn't have lots of them. It's I think 20. So we see how they look, and what can we do more. And what we are doing here, so it's the same. So we are putting the water geometry in the data string. It will contain the coordinates for those polygons. So we'll just use those polygons and put them in X and Y, and we will add those points on the graph. We can use the line width. We can check, like for example, we can use different line widths for the drawing. So you see now it's a bit more. Okay. It will list all 20s. So you need to wait, or this is, you cannot close this one. Okay, so you can experiment with this one. This interactive mode is used. This interactive mode is used so we can actually close graph and print another one, and we don't want access, and we just we just pause it for 1 second so we can see the picture, and that's why we needed to import time, as this is the library for the delay. So we have this delay 1 second, and close the graph. And if this fails, if it's unable to catch the coordinates, then it will just print that it failed to print coordinates, but it will pass further, so it will try to draw the next polygon. In this example, we will actually use the random. If we use CISAC, for example, we will always get almost the same picture. So we can get random things moving on, so we will get the different things. So let's do this. So here we have the same thing again, but for the first test, we will here make the width a random number. So for the line width we will use the random number from 5 to 15, and we will use the random rotation. So we will use the rotation from 0 to 360. So and yes, we will plot the diagram with the line width, so that's different from the last part, and we will just use the rotation plus base, and the rest is actually the same. We can set this to 1. Okay, and we can set okay, CSAC is not having a lots of polygons, so we can try to run this. Okay, it's downloading as this is new folder, so it needs to download the data from the CSAC. And now you can see that the line width is actually random. Okay, yeah, this is thicker, this is more. And if you remember one of those polygons, you will see that it's actually different when we run it again, as it will get a different rotation and different line width. So those two things are different. Okay. And later in the code we will also use displacement from the center, so that we move those polygons around around from the center. In the part 5 we will get into more complex code and check some other things. So we can open part 5, and in this part we will use the OpenCV, and we will have the multiple cities in the array. So in the Python you define the array like this, and you fill it with the data. And again, it would be boring to repeat the cities, all the cities at every time, so we just generate another array. We just create another array, and we are taking just the random cities. So here we have for all cities in the range, use the random at least 2, maximum all, and append it in the num city array. Here we are using the random rotation. We are printing rotation, and we will run the main loop few times. So here is the random number of so we will run it at least once, and maximum 3 times, so it gets through all the cities, selected cities, and get the waters from them. We will have the random displacement enabled, so the water can be displaced around the map. And here we have the random object size. So sometimes in the cities we have big rivers or some big lake, and we want to remove that from our map. So this is a way not to select the object, so we will generate the number between 1 and 500, and if the number is higher, so if the river is bigger than 500, then we will not include it in our graph. Here we just start the code. It's for the random number of times, and for each city that is selected to be in this loop, we are creating the queries for the getting the natural element water, and we are starting to build our graph. If we take a look at this line, so it will generate the random number from 0 to 100. If the number is more than 2, it will just skip all of this, so it will not draw this object. But if the number is less or equal to, it will continue to the drawing, to adding the geometry to the graph. And I added some randomness to the displacement. I don't know if this is working, so I need to recheck this one, but those lines. But yeah, here we want to add some displacement of the polygons, and here we are just using the same as in previous part. It's just a rotation of the object, so it's random rotation. And in those lines we are just checking if the size is what we want, so we want to skip some sizes. So if the size is less than what we want, we will print it. And if some of this returns error, it will just continue and continue to a next loop, so it will just skip this error. We already had this one, so we are just taking the exercises and we are checking the minimum maximum. We are removing the axis, we are doing the random zoom, so it will generate the number from 1 to 10, and here it will generate from 1 to 15 and do the random zoom on the x and y axis. And this time we are also saving the picture, so we are using the save fig to save the picture in generated PNG in the directory where the Python is run. And the reason why we are saving the picture is that we want to check some information about the picture, and in this case we will check the number of white pixels. Sometimes we don't want completely white picture. That means that nothing is generated or nothing is on the screen, or sometimes we don't want a picture to be without white pixels, so it is maybe too many objects. So if we change that, we can get a whiter or a picture with more data shown, and if those conditions are satisfied, then the picture will be shown on the screen. Yeah, we need to wait for 10 seconds, so I can okay, so we already have multiple colors, we have multiple objects, we are rotating them, we are moving them around. Okay, so let's press Ctrl C. So we need to wait this on this for the 10 seconds, so the code can exit. Okay, now we have 1 second, and so we can, for chance to show, so we can set here 20% of a chance, and we can also put here probably like something like this. Okay, so let's run it again. Okay, now we have more objects, but you saw the white ones, so it was, yeah. so we can get more white or less white, or we can just be more selective with so we will now get more white pictures and completely white pictures, but we are free to change the parameters, so we can get more things on the picture or less things. So okay, the code is not perfect, so it will take some time to break, so you need to press Ctrl C for a break. So and we can change this to 1, and we can maybe select this. We want maybe less white, and we can add maybe more, so 50% of chance to get something on the screen. Okay. It will first download the data, and now it's actually generating the pictures, but the white pixels are too low, so it will not show the picture if it doesn't fit in this area. So we will need to wait more, or we will need to lower this number. Okay, let's kill this and let's try with this. And we can always check that number. So now you see we have something around, what is this? This is in thousands. Okay, we need to lower it a bit more. Okay, so let's put here probably like this. Yeah. Okay. And on the last part I will show you how to put the picture on the full screen, because we needed that on the exhibition, so we wanted just the screen that is showing the pictures, not the code or the graph or something like that. So in this part we will also need Pygame. So Pygame is great for showing the full screen images or doing something on the image, so we just use that. We are just initializing the Pygame, and we are setting the screen and the image size. As in this sample we will have the full screen with four pictures that are generated. And here is just the list of the cities, so we can add more or have less, it depends on what you want. And this part is just for the Pygame, that it knows when you want to exit, so if the key down is pressed, then it will exit the full screen. You already know this part of code, so it's just random numbers and just a query of the water types. It's doing the moving the objects around, doing the rotation, We just want to know if picture is generated or it is not, so we know what to go to go or not to go to next pictures. We want to know if picture is generated or not, so we can go to our next one, and we are just plotting it to a screen. And here we are just checking if the picture is generated and ready. If it's ready, we will save it in the PNG. And again, we will check the white pixels, and we will do the counter. So we will just save the picture as a picture 1, picture 2, picture 3, picture 4, so we can line up those on the screen. We will load all 4 pictures. We will resize them so they fit the screen, and we will set the background color of the screen, and we will just display those pictures. And at the end we will update the display, and we will wait for some time, so just to leave the user to check the pictures, how they look, or are they similar or something like this. We will not use full screen here, as we don't need it and it's harder to exit and we don't see what is happening, so we will use just this line that is setting the screen to be in the window. Okay, let's try to run this. So okay, so we have 4 pictures, but they will change. So it first load the same pictures on. Okay. And now you can just play with the parameters, so you can get different pictures, different cities, different line widths. Yeah, and here it will, if this number of white pixel doesn't fit in the range, it will not put the picture in here. So that's why sometimes it just waits and generates another one. So let's change few parameters here. So we want here a bit more chance to get the element, and we probably want something like this. That should be okay. Or break here. We will need to wait those few seconds. Okay, we can save and start again. Yeah, now we get more diverse pictures. I want to thank you and hope you enjoyed the workshops, and yeah, try to change some numbers here, try to get the different things running.
If you have any additional question, you can contact us on the Discord, or you can open an issue on a GitHub.
So if you have any issue with the code, or you have problem understanding some bits of the code, so you can just open the issue, and you'll probably need to open the GitHub account, but here you can add an issue. I will open one issue with the Discord link, and later I will put the Discord link here, so you can go to that link and have direct chat with me and have direct support on the Discord. Okay, so when you are here, just go to issues and you can open new one, or see the Discord link.
In future, we are planning to do different things with this code. So for example, we would like to add AI, so the computer would have more realistic, so we would have more realistic pictures. If you have any feedback, it would be great, so that you contact us and to leave a feedback, or just change something in the code and get different results. Thank you for watching, and bye.